Hello everyone. In this video, I will continue talking about concrete mix design. I will talk about how to evaluate whether or not we need to use air entrainment. Air entrainment is required whenever concrete is exposed to freeze-thaw conditions or de-icing salts. In some situations, air entrainment is also used to increase workability. From this table, you can see the recommended air content depends on aggregate size and also the exposure conditions. In the first row, it shows the estimated air content for non-air entrained concrete. Those are the air voids naturally formed in the paste structure during the hydration process. And in the following rows, you can see the recommended air content for air entrained concrete, and they include both the naturally formed air voids during hydration and also intentionally entrained air bubbles by using air entrainers. The exposure condition is categorized into mild exposure, moderate exposure, and severe exposure. Mild exposure means the concrete is not exposed to freezing and thawing conditions or de-icing salts, and air entrainment is used to just improve workability. Moderate exposure means some freezing exposure occurs, but concrete is not exposed to moisture or free water for long periods of time prior to freezing. And severe exposure means concrete is exposed to de-icing salts, saturation, and free water. For example, if we have nominal maximum aggregate size 19 millimeter, and the concrete structure will be in moderate exposure condition, then from this table you can get the recommended air content, which is 5%. In general, the recommended air content decreases with increasing aggregate size. Okay, so let's talk about the next step in the mix design, that is how to determine the workability requirement for the project. The concrete needs to be workable, but no segregation or excessive bleeding, which means the coarse aggregates will migrate to the bottom and water will migrate to the top. We don't want to see that happen. You can increase slump by adding admixtures, including air entrainer, water reducer, and super plasticizer. Or you can use rounded aggregates instead of angular aggregates to increase workability. So this table provides recommendations for the slump used in different types of projects. So you can check this table, what's the maximum slump and what's the minimum slump for your project. In general, slumps increases about 25 millimeter for each 6 kilogram of water added per meter cubic of concrete. So the value of slump is directly related to the amount of water you used in the mix design.